We're going to look at the idea of combinations versus permutations. Essentially, we're going to try to look at the differences. And this can be really confusing. So we have our two formulas here, usually written N choose R, or NCR, and NPR, P standing for permutations, C in combinations. And you can see the two formulas. Okay, these are the two formulas for both. We have to say what N and R are. N is your number of choices. Okay, choices, and R is the number you'll choose. So number you choose. So what we mean by that is obviously you can have 10 choices and choose 10, and then depending on which of these two you're referring to, you get very, very different answers. Our question here is we have some visuals too. Our question says choose 3 of the 7. And by 7, what we mean is I've made 7 little objects here. We have this spray paint, 2, 3, 4, 5, 6, 7. So I just chose 7 objects. They're all different to help us with some visuals for this. The first thing we're going to do is talk about a permutation. And a permutation is where order matters. Okay, and that's important here. So order matters. Okay. That's going to be big for us. Order matters in the permutation. Order does, actually, I don't want to highlight does. I want to highlight not. Does not matter. Okay. So those are two very different ideas, where order matters and order does not matter. So first we'll actually work with the permutation. It's pretty simple with the numbers we have. Our N is the number of choices, which would be 7. Okay, so for both of these, our N is going to be equal to the value of 7, and our R is going to be equal to the number 3. So for our permutation, our NPR, okay, because N is 7 and R is 3, we can replace them with those two numbers. Okay, so we have 7p3 is equal to 7 factorial over 7 minus 3 factorial. Okay, we'll talk about how we can simplify these factorials. So 7 factorial is the idea of 7 by 6 by 5 by 4 all the way down to the number 1, right? And maybe I should write it all out because actually you're going to help us with desimplifying. So yes, I'll write that all out. 4, 3, 2, oh, that fit perfect. On the bottom, this ends up being the number 4 factorial. So we're left with 4 by 3 by 2 by 1. Does that make sense? Now, because this is all multiplication, one way we can simplify this, say you didn't have a calculator, is essentially they call it canceling. They all divide to each value of 1. So really you're just left with 7 by 6 by 5 in this permutation. Okay? 7 by 6 by 5, I think, is going to give us 210. So what that's saying is you can choose 3 items 210 ways. So maybe you're looking at these items going, how on earth can I do this 10 different ways? We'll start with an example. We just have to choose 3. So the first 3 I'm going to choose is, oh, I don't know, we'll choose this spray paint, this red and blue, and this star. And already we have the idea of that being 1. Now I'm obviously not going to show 210 ways, but I'm going to show you how this can pick up really quickly. Next, because order matters, okay, I can start again with this brown piece. I can go with the red dot, and then I can just substitute another thing in for the end. Okay, and we're going to go through that idea so many different times. For the third one, we could do this again, and this, and you'll see that this concept means they're going to really add up. Like you're going to get a ton because the order matters. So what it's saying in this case is even though there's already one that has a black dot, an orange, and a yellow star, I could do another one, okay, and this is where order matters. I can do black dot, star, orange, okay? Now in a permutation, this counts as a different combination. But in a combination, I guess I shouldn't have used the word combination. This is a different, in a permutation, this is a different order, okay? But in a combination, these two things are equal, and therefore you wouldn't count that. Okay, so that's why our answers are going to be very, very different. So let's now do the exact same idea with a combination formula. So our combination formula, our n and r is still the same. Let's go down. And this time we get 7 choose 3. We get 7 factorial over r factorial. R is our 3. Multiplied by n minus r. So that's 7 minus 3 factorial again. Okay. If we kind of look above, we can kind of cheat our way through this. We know that this part here is going to just equal 7 by 6 by 5, and then we have that extra 3 factorial at the bottom. Does that idea make sense?
Yeah.
Yeah? Okay, so I'm going to skip to that. If that doesn't make sense, just write it out the long way, okay? Or just use your calculator. But essentially, we end up with 7 by 6 by 5, because we've already figured out we can cancel out a bunch of that stuff. And the only addition on the bottom is our 3 factorial, which is 3 by 2 by 1. So that kind of changes this. Now we're dividing by the value of 6. So 7 by 6 by 5 we said was 210. And 3 by 2 by 1 is 6. And this now ends up being, how many times does this fit in? 3, 5? I think it's 35. Check it with your calculator there. Okay.
Yeah, 35.
35. Okay. And that is because of that idea we talked about earlier, that this and this are now the same thing. Okay. So what it's saying is, and because we're choosing 3, I'm going to show you why the idea of this choose 3 here. I can show you just using this one. We're going to use the star here. I'm going to take this one out. I'm going to rearrange the order. Okay. Here's a star again. We'll take this guy out. Actually, I can just delete him. Delete, because I want to show you the idea of different combinations of them. Here's a star. Have we already used this one? Yeah, we have. So let's do this now. Okay, so let's see if I can notice. I'm going to go black, red, blue, star, red, blue. Okay, then we can do red, black, star, red, star, black, and then we can do star, black, red, and star, red, black. Okay, did that one show up? Oh, I don't think it quite did. Come on, thank you. Okay, black. Okay, so if we quickly count here, 2, 3, 4, 5, and 6. Now, in a permutation, all of these are different, right? But in a combination, all of these are identical. They're all using the same 3 pieces. And if you look below, this is where it's getting important, we divided the same idea from before. We divided by 6, where here we didn't divide by 6. We just had 210. Well, if you take a look, we have 6 of these. So in a permutation, we count all 6, but in a combination, we divide this value by 6. When you divide 6 by 6, there's only 1. So in a combination, it sees these as just one type of order, but in a permutation, it sees it as 6. So whatever we divide by, that's pretty much telling you how many duplicates there are when you go through that idea. Okay, and if we type this into a calculator, 7p3 and 7c, let's see if my calculator, I think it has that function. Function, permutation, oh, I might be lying. It did have it. There they are, combination. Let's do a combination. Okay, so the combination said 7, choose 3, okay, and it said 35, right, exactly what we said before. And for the permutation, I'm just going to show you how it works on the calculator too. For the permutation, okay, same idea, 7, choose 3, and 210. Very, very different answers, okay?